In this lecture, we are going to study about extreme values of a function. So we are going to give the steps on how to find extreme values of a function. So to find the extreme values of a function, use the following steps. Step 1, find all the critical points of f in the open interval AB. Step 2, evaluate f at each critical number. I say critical points or critical numbers in this open interval AB. And then number 3, evaluate f at each endpoint of the closed interval AB. And then lastly, number 4, the least so the list of these values is the minimum and the greatest of these values is the maximum. So these are the steps. So let's do some examples. Before we do some examples, just remember that let f be defined at C if f prime at C equals to 0, or if f is not differentiable at C, then C is called the critical number of f. And then, so here are the pictures. So you can have this. So this is the C. So at this point, f prime of C does not exist. At this point here. Or we can have this. You see at this point here, we can draw a horizontal tangent here. So f prime at C is 0. This horizontal tangent. Or we can have at this point here, f prime at C does not exist. Or we can have this. So at this point, can have a horizontal tangent here. So this f prime at C equals to 0. So this point C, this horizontal tangent. And then another thing that you need to remember, that relative extrema occur only at critical points, critical numbers. So this to say, this is like a theorem. So if f has a relative minimum or a relative maximum at x equals to C, then C is a critical point. So that's what we have. So let's do some 2 examples. Find the extrema of this function f of x equals to 3x power 4 minus 4x power 3 on the interval -1 to 2. So just follow the steps. So solution. So we'll find the derivative of the function, which will be 12x cubed minus 12x squared. And then remember to find the critical points critical numbers are found from this equation. So therefore, to find the values of C, just say f prime of C would be given by 12c cubed minus 12c squared equals to 0. So this is the same as C minus 1 equals to 0. So which means that C equals to 0 or C equals to 1 are the critical numbers. So therefore now we test now. So we can draw in form of a table. Left endpoint, critical number, C equals to 0, critical number, C equals to 1, and then right endpoint. So which is given by x equals to 2. So f at 1, negative 1 is 7, f at 0 is 0, f at 1 is negative 1, and then f at 2 is 16. So clearly when you compare all these numbers, you get that this is the least value, so this is the minimum, and this is the maximum. So therefore we say, so therefore the maximum value of f of x is 16, which occurs at x equals to 2, and the minimum value of the function f is negative 1 at x equals to negative 1. So that's how we solve that problem. Problem 2, find the extrema of f of x equals to 2x minus 3x2 over 3 on the closed interval minus 1 to 3. So as usual, we start by finding the derivative. So solution. So the derivative of this function will be given by 2 minus 2 over x raised power third, which is the same as 2 into x raised power third minus 1 over x raised power third. Now critical numbers or critical points are obtained by setting f prime to 0. Clearly, this is what we have. So we set 2 x raised power third minus 1 over x third equals to 0. means x power third minus 1 equals to 0. So x equals to 1 is one of the critical points. But so f prime at 1 equals to 0. So which means that x equals to 0 equals to 1 is a critical point or a critical number. But also the number x equals to 0 is a critical point or a critical number because f prime at 0 is not defined or does not exist. So you remember the definition of critical number. So therefore we have this point. So we have now to test. I have to test left endpoint x equals to -1, critical number, x equals to 0, another critical number, x equals to -1, equals to +1, and then right endpoint. X equals to 3. So f at -1 will give us -5. F at 0 will give us 0. And then f at 1 will give us -1. F at 3 gives us 6 minus 3 cube root of 9, which is roughly -0.24. So from these values, we can easily see that this is the minimum, and then this is the maximum. So therefore, we say the minimum value of f is -5, which occurs at x equals to -1, and the maximum value of f is 0, which occurs at x equals to 0. So thank you.